Our simulation of the spread of disease uses a lot of random numbers. For example, at line 37 here, we find this: random, open brackets, 100, close brackets. What this is telling the computer to do is to pick a random number between 0 and 100. So this 100 is our upper limit for our random number. And what this section here is doing is comparing our random number between 0 and 100 with our infect prob. You might remember infect prob is the probability of an infection, and we set that up here. So it's the probability as a percentage of a cell being infected. So what happens is our random number is selected, it's compared to our infection probability, which as we just saw is set to 1. And this line here, if, is an if statement, says that the computer should do something if our random number is less than our infection probability. So with our infection probability set to 1, our random number between 0 and 100 is only in very few cases going to be smaller than our infection probability. If instead, for example, we'd set our infection probability to be 50, then on average, half the time our random number will be less than our infection probability, and half the time it will be more. So this section here randomly decides where the disease outbreak is going to be. And if we look at line 40, we can see the same thing in action. If something or other, then. And this case we're comparing a random number from 0 to 100 with our immune prob. Again, we set that up at the top. So if our random number between 0 and 100 is less than our immune probability, then the computer will run this next bit of the simulation. And at lines 49 and 50 here, we see the same again. This symbol here, this colon followed by equals, that means set the thing on the left to equal the thing on the right. So in this case we're setting the value of x to be the value of this random number. Now in the two previous examples we had our random numbers simply as numbers, but in this case what we've done is we've used a name instead of a number. So this name width represents a particular value, and we set that value back up at the top. Here at line 2 we've set that width equals 100. So now anytime we use the word width, so here in line 49, the word width, the computer knows that that means 100. So once again what we're asking our computer to do is to pick a random number between 0 and 100. If instead width had been set to 50, the computer would choose a random number up to 50. Using names is a neat way to make sure that your random number is always within the right limit, even if you decide to change what that limit is. Back up here, if we change width to be 50 or 10 or 1000, the computer automatically uses that new value when it's finding this random number. So these two lines taken together, what they're doing is randomly selecting a pixel, randomly selecting a cell within our canvas, and that cell is being called XY, so we're choosing somewhere randomly within the width and somewhere randomly within the height. So there are quite a lot of random numbers in this model, but have you ever noticed what happens if you run the simulation twice? Let's try it. Let's run it once, pause it there, look very hard at that for a second, because what we're going to do is we're going to run it twice. Here we go, running it again. In spite of all the random numbers in our simulation, we get exactly, pixel for pixel, the same output. We could run it a third time, and you see we still get these 3 blobs that gradually grow. A fourth time, exactly the same again. So what's going on here? Well, computer random numbers are not really random. Computers just do literally exactly what you tell them to, for better or worse. They have no freedom, and they wouldn't be able to create something that is truly random. Instead, they generally have lists of random numbers built into them that have been generated by something else that can be truly random. The computer then just works its way through this list. This is what's happening here. At each point where we use a random number, it always uses the same ones, because those are the random numbers next on the list. The way to change this and get something more like a random output is to change how it chooses where in the list of random numbers it begins. And this is called seeding your random number. If we look on line 29, we have rand seed 25. So what this is doing is it's setting 25 as our seed every time. And that seed determines where in this list of random numbers we begin, so we're always starting at the same place and always using the same set of random numbers. So let's quickly run it once more. See our familiar 3 blobs of disease growing. If we change our random seed to, well, we can change it to anything. Let's try 30. If we run it now, we get a different pattern of disease. Sure, we've still started with 3 blobs, but they're in different places. Let's change it again. Let's put it at 100 and see what happens. So now we've definitely got a different pattern of disease. If we get rid of this line, either just by deleting it or using curly brackets so that it's ignored by the computer, then the computer will automatically use the time now as the seed, so that every time you run the simulation, it will get a different seed and so a different set of random numbers, giving you a different outcome. So we'll have something different every time.